This is the final 3.6 review question. Calculators are allowed. Number 10, this is a free response. So we'll talk about the point breakdowns in addition to figuring out how to do the problem. If we read the problem, it says we want to consider this curve defined by a negative 6y cubed minus a 3xy plus an x cubed equals a negative 82. Our first job, worth 3 points, is to find the derivative of y with respect to x. So this is that same task we've been doing for quite a while. We will need to take the derivative of the left, and we'll need to take the derivative of the right. Both of those derivatives will need to be in terms of x. So if we look here, first I will hit this negative 6, I pass through it. Then I hit the power rule, I leave the inside unchanged, and then I take the derivative of the inside with respect to x. On this one, the biggest mistake that people will make is they will neglect to carry the negative 3 through the entire product rule. So I'm going to attach that negative directly to the 3 so that I don't accidentally forget it. So if I set up my template, first times the derivative of the second plus second times the derivative of the first, then I will have a negative 3x times the derivative of a y plus a y times the derivative of a negative 3x. Then I go to my final term, which is a 3x squared, and the derivative of the right, which is a constant, is 0. Again, you will miss points if you put a dy dx here, or if you neglect to do the equation and you just do the expression and then suddenly have an equation when you're done, or if you forget to take the derivative of a constant and get 0. So this process, what we've just written right here, is worth 2 points. Once we're here, we need to isolate the dy dx. So we identify the terms that have dy dx in them. And there are 2 of them, whereas there are 2 other terms that don't have dy dx's in them. So I'm going to leave the dy dx's on the left and factor out the dy dx. So inside I'll have a negative 18y squared minus a 3x. And on the other side, I will have a positive 3y minus a 3x squared. So if I isolate dy dx, then I will get a 3y minus a 3x squared on top, and an 18y squared minus a 3x, negative 18, excuse me, on the bottom. Now, if we look at the answer key that I have, I actually factor out a negative 3. So I get an x squared minus a y, and on the bottom, I'll factor out a negative 3 as well and get a x plus a 6y. So you don't have to do this, it just makes some of the additional parts a little easier. So that negative 3 will cancel, and I'm left with an x squared minus y over an x plus a 6y. So this final solving process gets you another 1 point. Okay, part B, we want to write an equation for the line tangent to the curve at the point. So to write equations of lines, we need a point and we need a slope. We already have the point. The slope will be this derivative that you just computed, which is x squared minus y over x plus 6y, evaluated at the point. Remember, you can't have slopes with variables in them that involve x, because then what you write will not be the equation of a line, it will be the equation of something else. So if I plug in 5's for x's and 3's for y's, oops, then we end up with a slope of 22 over 59. Not very pretty, but we can still write the equation of the line now. So my line will be y equals the slope times x minus the x coordinate plus the y coordinate. This is worth 1 point for the slope and 1 point for the line. So far we are up to 3 points plus another 2 points. We've done 5 points already. We've got 4 more left and 3 more parts. So that tells you these final parts aren't worth a whole lot. Okay, so part C says there's a number k so that the point 5.2k is on the curve. Using the tangent line, we want to approximate the value of k. So what we're thinking about here graphically is, let's say we have some function and then we have a tangent line to that function. Well, if this tangent line happens at 5, 3, and then I move 0.2 away, so this is obviously not to scale, but we can kind of see, here's my 5.2 that's on the curve and on the line. On the curve, we have a 5.2, k. On the line, we're going to have what comes out of the line when I plug a 5.2 in. And this y-coordinate here will estimate or be close to this y-coordinate here, because we've only moved along the line 2/10, which means we haven't had much opportunity for that curve to get far away from the line yet. So this is asking us to figure out what is that approximate value. So k will be approximately equal to this line up here with a 5.2 plugged in. So that's a 22 over 59 times a 5.2 minus a 5 plus a 3. If we get out our calculators and plug it in, we have 22/59 times a 5.2 minus a 5 plus a 3. Diamond enter. We get 3.074 or 3.075, depending on whether you truncate or round. And either one would be sufficient. You'd get the point. So 3.074 or 3.075. Doing this process is worth 2 points. You get 1 point for plugging that 5.2 into the equation of the line, and you get another point for the approximate value. So if you say k equals that, you're going to miss this point. You got to make sure that it is the approximate value. So that's your second point. So we have 2 points remaining. Part D says we want to write an equation that can be solved to find the actual value of k. So we want to know, what is k supposed to be? Here's our approximation that we got off of the tangent line. I want to know, what is it really? So in order to do that, we're going to plug 5.2, k into the equation of the curve. The equation of the curve was negative 6y cubed minus 3xy plus x cubed had to equal negative 82. So if I replace x with a 5.2 and y with a k, then I'm going to get the equation that I'm supposed to solve. So writing this equation is what they're asking for in part D. Notice that if I find out what k is, then this would become a true statement. So the point 5.2, k would be on the equation of the curve's graph. So if we look here, that's 1 point for writing the equation. In part E, we actually want to solve that. So that means we're just going to plug this into our calculator and solve it. So that's what we're going to do next. I'll go to my F2 menu. I'm going to solve for when negative 6 alpha k cubed minus 3 times 5.2 times k plus 5.2 cubed. That needs to equal negative 82, and I'm solving with respect to k. Now you of course can shortcut that and use x's if you want. I'm just putting in what we actually have on our paper. Bad light here. And we'll do diamond enter. Now ideally this true value that comes out should be pretty darn close to the value we found in part C. And if we look here, it's 3.075977, which is about 3.076. Notice how close that is to the actual, or to the approximation that we got off of our tangent line. So k in this case will be 3.076, or you could have truncated and got 3.075. So that's your final point for the 9.